Start recording now, and I'm sharing my screen. All right. So what I want to do today is I want to recap what we did last day, which was functions. And I also want to introduce the concept of file input output, right? So we want to talk about functions. We want to talk about file IO in C, which is basically reading from and writing to a file in C. And just to recap functions, there were three parts of there were three important things that we had to remember when using functions in C. And anybody could remember the three parts of utilizing user created or programmer created functions in C? We had three important parts. Anybody?
So you had a function call or a declaration.
Right. So we had a function call. We had a function declaration.
And a function definition, so.
Right. And a function definition. And your function declaration is just like a variable declaration in that you specify the data types associated with the function. So in your function declaration, if your function did not return anything, you would say that the function had a return type of void. And then you would also then have your function name. And if any variables were being passed to your function, you would declare the type that would have been passed to your function as well. So like how I put char there. And this specifies how many variables your function is expecting. Your function call happens inside of your program execution, right? It could happen from inside of your main, it could happen from a different function. And your function call, in this case, if your function is void, it's not expected to return a type. So we don't have any variable accepting any value from where this function is called. So you would just see function name, and of course you have to, right? If I had a variable char ch, I will pass ch to my function. Hold a second there, I find my computer running a little laggy this morning. Don't know why. And of course, your function definition is where you actually outline the code or the functionality or the purpose of your function. You write the statements that your function represents. So again, your function definition, you have to specify the return type, and if it's void in this case, your function that is defined is not going to have any sort of your function defined is not going to have any sort of return statement associated with it. You could write void. You will put the name of the function, so the compiler knows that this function is not, the compiler knows that this function is defined down here, and you have to declare your function variables. So these variables here, right, doesn't have to be the same name as the variable that is passed to the function. Or what X is going to get, X is going to get a copy of whatever value was in CH. So if CH contained the character exclamation mark, when this is called, CH will copy the value of exclamation mark to X. And of course, whatever code that you have inside of here, is going to be executed, right? So this is your function code. This is your function code. Any issues there? This is what we remembered from last class, right? Yes, no?
Yes, sir.
Right. So last class, we had some homework, and I actually said that I would have put it up as an assignment, and I did not. So I have to remember to put that up so that you all could load up the assignment there, right? But I just want to recap the code that we actually wrote for functions as well. Okay, so we did 2 examples with functions. We kind of created our own value, our own function with to the power of. And this here, of course, is the declaration of the function. And what does this tell us? This tells us that the name of the variable is to the power of. And it expects 2 integers to be passed to it. And it will have 1 integer value being returned from it. So we inside of our main, we ask the user to enter 2 variables, A and B, and then we, inside of the printf statement, call the function to the power of A and B. And it's expected that in the same way that we have A being represented inside of this %sign D, %sign D, and B represented inside of this %sign D, when to the power of is called and it does what it has to do, the value that is returned from to the power of will be represented by this %sign D here. So in this instance, we did not use a variable to capture the value returned from our function call. And of course, we have our function definition. So when we defined our function, we of course, again, declare the return type. We put the name. We have some variables to hold the values that are passed to the function. And we do the code that the function is expected to do. And this return statement here says whatever value is inside of R should be returned to where the function is called. Let's take a look at the second example that we did. I think the second example was the one that was left open for all right, so the function, we had multiple functions in this example. And we had, of course, with varying return types and varying values passed to the function. So we have one function with 2 integers passed and 1 integer return. We have one function with an array passed it and a single character passed it and an integer getting returned. And we have one that has nothing being returned but two integers past it. And we said that each one of these functions had a different purpose. And it was called, of course, based upon a menu. And we actually had a menu function as well. And the menu function did not take in any value. And the menu function did not return any value. The purpose of that menu function was simply to display the menu to the user. And how we utilized that was that we put the menu inside of an infinite loop. But we know that this here, we could utilize the infinite loop in this instance because of the fact that the menu has given us the option to be able to break loose from the infinite loop by giving us the option to exit. So we want this menu to run infinitely unless, of course, the option to exit was entered. And we have the other three options, 1, 2, and 3, being selected via switch statement. And we have our catch, our default catch, which will tell us if we entered something incorrectly. And depending on the purpose of this, depending on the option selected, right, we would call a different function, do a different task, and send those values to a different function, which of course we had to populate. Okay, so let me write that down to just allow you all to upload the answers. All right, answer upload for function exercise. Okay. Anybody have any issues with functions at this point? The concept of it. I know that we mightn't be professional at implementing them at this point. Yes, Hazan?
Oh. Yes.
Uh-huh.
Yeah, I was gonna ask, what were we really supposed to do with the second one? So like ask user to input like an array and a character to see if that character in the array.
Not just to see if the character is in the array. The name of it is character frequency.
Oh, okay.
So we have to see how much times that character appears in the array.
Okay. No problem.
No problem. Anybody else had any questions? Anybody else had any questions? No? All right. Okay, and of course the print prime would of course print any prime numbers that exist between these two. Now I'm going to go now into the file input output in C, right? And in terms of file IO, in C, we just want to talk about the purpose of utilizing files in the C programming language, right? The purpose of utilizing files in the C programming language. So why would you want to use files in a programming language? What do files allow? Anybody could tell me what is the main advantage of, if you could think about it, what is the main advantage of using some sort of files in C?
So you could input data, we could get data from an external source other than the
Right. Okay, so yeah, it allows for another means of being able to read data into your it allows for another means of reading data into your programs. Okay. Anything else you could think about that why files might be useful?
So is it more organized?
Um, I could take that as a soft point. Yes, files could have a specific order to them, right? That of course, if you have your data inside of a file, it could reduce human error in a way when you're reading in large amounts of data. But what have we noticed about almost every program that we've written so far? Almost every program that we've written so far. What have we noticed about it?
It makes a separate exe file.
So yeah, well yes, every program that's in terms of the creation and being able to execute the program. But I was hoping to hear that somebody say that we haven't had any sort of persistence of data with our programs. Every program that we've written so far, we've had to enter data into it, and when we come back, there's nothing from what we entered before. And so the major advantage with files is that we have the ability to work on a program, generate some sort of data, and save that data and come back to it at a future point. Because everything that we've been doing so far has been everything that we've doing so far has been start writing a program, running the program. The program exists in memory. But once we finish with the program and we stop the program, there is no more data associated with that program from the session that we've used. And what files could allow us to do is files could allow us to save data so that when we come back, we could see, what was going on last time. So it comes like if we write a program, and that program, let's say, is a little maths game. It's a maths game. And we say the maths game will give us a series of questions. And, what we might want is to see who has the high score. Or we could even go so far as to try and see who has the highest score in the shortest time in the maths game. How do we get that done? That data has to be stored to, your file. So your program exists on your hard disk drive when you write it, right? So your HDD, when you write it, this is your program here. But your program, in order to run, has to be loaded up into the RAM of the computer. So in order to run, we have to load that program into the RAM of the computer. While that program is operating in the RAM of the computer, data is here, right? The data is inside of the RAM. But what we want is we want to come back to this data. We want to come back to this data at some point in the future. So for us to be able to do that, we have to be able to write not have the program here to load up into the future, but we also have to have the data, right, to be stored in some sort of file on the computer system, so that the next time that we run this, we'll load up the data from the hard disk drive and we'll load the file up also to be able to continue using that data, in the future. You guys understand what the concept is behind this? Yes, no, yes.
Yes,
no.
sir.
Right? And we're going to start pretty simply. We're just going to write some data to a file, and we're going to read some data from a file. Okay? This is where, however, some of you who are using online compilers are not going to be able to stay with me in terms of I don't know how the online compiler is going to work. Excuse me. How the online compiler is going to work for creating the file. So if you're on a computer and you have the code blocks on the computer, that should be fine. And what I would suggest is just like before, right? Just like before, I would have suggested that on your computer system, on your C drive, you create a folder with your name _C. And this folder is where we can keep the files. Okay, this folder is where we can keep the files. So for ease of use right now, whatever your name is _C, I actually have my _C folder stored inside of another folder on the computer. But for ease of use and for just the purpose of doing this class, I will store my information on Valdez _C. Is that fine?
Yes, sir.
All right, wonderful. All right, so we're in C. Are we going to start a new file? All right, start a new program. We want to call this program file. Let's call it first_file.c. First_file.c. And we start off like normal. We include stdio.h. And we include stdlib.h, right? Int mean. And then we have, I'm put my return 0 here because I tend to forget that. And we can start. And the thing with files is that files use file input output use pointers. So we have to declare a file pointer. You have to declare a file pointer, and it's of the type file, data type file. So we go file and FP, meaning file pointer. File FP, meaning file pointer. And we use a function called fopen, right? To use a file. I don't know why my writing pad today is it's not moving as smooth as normal, so forgive me. Right? In C, we have to use the function fopen. So we have a function that allows us to open a file. And in terms of opening files in C, our function would look like this, right? We would declare file FP being our file pointer, and this is the point at which where in memory that data associated with that file is read, right? And then you could say FP, let me put dot here so that there's going to be code in between these two. FP is equal to fopen, and you have to put the location of the file, right? You have to put the location of the file. So you could put C : / because 2 backslashes mean 1 backslash in C, right? Valdez _C / file.txt. And then you also have to put the mode in which you have to read the file. So this first part here is the file location. File location. Oh my God, I don't know what's going on with this thing today. Hold on, let me unplug it. Because it's not treating me well. Right. So we have the file location. And then the next thing that we have to put into fopen is the file mode. And we could, for now, I will put W. And anybody wants to get what W stands for? Anybody wants to guess what W stands for?
So window.
No. It's nice guess though. Huh?
The operation writing.
Yes. Right. The operation, it stands for write. So we have file mode, right? And this W. This W means that we want to open the file to be able to write to the file. Okay. And we have some different file modes that we can utilize, and I'll paste the different file modes into here. So okay. So the two modes that we will focus on for now are R and W. But we have 6 modes in total, right? We have R, we have W, we have A, we have R+, we have W+, and we have A+. Reading mode, the reading mode will read data from a file, of course. So reading mode would read data from a file. The writing mode will allow us to write information to a file. And if the file does not exist, it will create the file. So if we open a file for reading and the file does not exist, we are going to get an error. If we open the file for writing and the file does not exist, as long as the location is valid, it will create that file, right? If we open this file for appending, the file doesn't need to exist. It will create the file. But what appending means is that if data already exists in the file, it will attach it to the bottom of the file. So it will continue writing data to the file, right? If we open the file in R+ mode, you could open the file to read it and also to write it. W+ will also open a file for reading and writing, but it will overwrite any data that existed in the file previously. So you can write data to the file and then read data from that after you've written. And then A+ will open the file for reading and writing. And again, if information needs to be added to the file, it will add it to the end of the file. For simplicity's sake, I normally just use these two with you all. Append is fine, but you have to know how to use it. And it's very important when you are working with files. It's very important when you are working with files to ensure that when you're working with files, it's important to ensure that you keep to the format of your file. Because if it is that you have your file and you operate in it with a specific format, you operate in the file with a specific format, and you're operating the file within a specific format, and then you write to the file, and you write to the file, and that file's format, it doesn't match up. Then when you read from the file in the future, it's going to crash. The program is going to crash. So the format in which your file is written has how data is represented in your file is very, very important. Something as simple as having an extra empty line at the bottom of your file could actually wreck your file, wreck your whole program. It could cause like a file read error, and then we'll have problems. So everybody's fine. Anybody has any questions on the file modes that we take a look at so far? Yes, no?
Yes.
I didn't hear the full what you said, David.
Said no, sir. All right.
Oh, good. So yes, Hazard?
Question. So is that how, like, when you're into your program, it's just going to the data, and like if you have a code or know to sum up all the values, you'll sum up all the values from the file or something?
If repeat the question.
Like when you're inputting the file, right? And let's say the file have like 5 numbers, and you have a function in C, so let's say to find the sum of numbers. So if you put the file, the function will find the sum of the files, of the numbers in the file.
Once you write the correct code to do so, yes. So you still have to follow the other rules of the programming language. You have to put the data from the file in the correct format, and you have to, depending, and I will show you the different ways to read data from a file, right? We have more than one way to read data from a file, and of course, that typically is based on the nature of the data in the file. So there are some files that you could read using one function and read that into a data type specifically, or there's another way that I teach that you read the data and it's all character data, and you do conversions to be able to get the data from the file. Okay?
All right, sir.
All right. But we'll go through it. All right. We getting I would say that file input output is the most difficult thing that we will do this year. Right? It's the most difficult. So this year we're about to get into is difficult only because there's quite a bit of ways to do the file input output, and There are quite a lot of ways to do the file input output, and you have to choose the right way, and it's just about knowing which is the best way to do what you want to do. Understood?
Yes, sir.
All right. So let's go into just simply doing the most basic of things, which is to be able to write a file to this folder, right? So the address to this folder is c/Valdez_C. So let's say, for instance, we wanted to write a file to this folder. Okay, so I'm going to write a file to a specific location on your computer, right? We will use fopen. So we will say fopen, right? And we have to say fp is equal to fopen. And then we put the location of the file, which is c://Valdez_C // and then the file name. So file.txt. Now notice that this file does not exist. Everybody agree with me on that, eh? We're going to perform magic here, right? So yeah, be astounded and amazed. All right, there's nothing there. And we need to put the file mode in, and let's put the file mode in as W. Because we know, right, if this file does not exist and the location is valid, then it will be created. Okay? If it does exist, it will be overwritten. It will be overwritten. And let me just go back to the notes to mention something as well. Just as we use the function fopen to open a file, it's very important, right? Once you are done with a file, right, use fclose to close it. And I'm putting an NB here. Because if you do not fclose your file, sometimes the data that is in what is called the file stream or the file buffer is not pushed to the file, and it's actually removed from memory, and you might lose data from your file. fclose ensures that you cleanly close off your files. Everybody understand? Everybody understand that? Everybody's good there? Yes? No? All right. Are you all still with me? Okay, good. All right. So if the file doesn't exist and the location is valid, it will be created. If it does exist, it will be overwritten. So let's simply ask the user for some text to write to this file that we've created. Okay? So we want to ask the user, so we use printf. We use printf to show to the user, and we say, please enter some text to write to our file. And if we have to enter some text to write to the file, then that means that we need to use a string to write some information. So char, str, sorry, 150. So we want to get some data. So we say get str. And please enter some text to write to our file. So get a string of text from the user. And we want to write that text, write the string of text to our file. So we want to write the string of text to our file. So how do we do that? Right? We have to use something called fprintf. Fprintf stands for file printf. It's exactly like printf, except instead of writing to the screen, it writes to the file. So you have to say which file you're writing to. So you have to put the file pointer here. Then you put in like a regular printf statement, %s and str. So that's what I'm writing to the file, right? And then after, we have to make sure to close the file. If you don't close your file, your data might not write to your file properly. So the fclose ensures that there is a clean close off or clean transfer of data from the data associated with the file in the memory of the computer with the data associated with the file and the storage of the computer or wherever the file is located. So you say fclose fp. And this, of course, will make sure we close the file properly. So in this instance, I am going to put half and half here, and I'm going to run this, and let's see if our file is created. And then when we enter some text, we'll see if there is any data inside of our file. I hope it works. So I'm compiling, no errors, so I'm going to run, right? You notice the file come up here. Everybody, are we astounded? Are we say, ooh, that was cool? Yeah, no? Somebody could have put the mic on and say, ooh, that was pretty cool. Right?
Yes, sir. Super cool. Really amazing.
Right? I'll take that as it is. And then we want to write some text to our file. So this is some text that I want to put in my file. When I press enter and my program is finished, and let's check the file. Right? The size is one kilobyte, so it should have some text inside of there. This is the file here. All right, let me close this off and open it back here, and you see. If I run the program again, and I have to close off this file, or else the file will be locked and I wouldn't be able to write to it. If I run the program again, look, from the time I run this program, look at what happens to my file. You notice that before that was 1 kilobyte, right? And now it's 0 kilobytes. It means that the data that was inside of my file before got overwritten. If I open the file at this point, there's nothing inside. But if I end up putting in some text again, new text, and I go back to my file, I have new text written inside of there. Is everybody fine with this? Yes? No?
Yes,
All right.
sir.
Yes, sir.
Pretty cool, pretty cool.
Thank you. Hey, I think it's pretty cool, right? Right. So programming is a lot of fun, and we halfway there on being able to write programs that have persistent information. So now I can write a program and put data in that program and come back and find the data that I put inside of that program. So, that now makes programs very useful. What I'm going to do is I'm going to pause now. It's 10 to 10. I'm going to pause now and we're going to go on break. And we're going to go on break and we'll come back in 15 minutes at 10:10 and continue with reading from a file. And then what we might do is that we might put these in some functions so that we could see now how we could read and write information from a file using functions. Okay?